Hello students, welcome back to the virtual class. Today we are taking up with the next chapter, that is progression. Okay, so progression. So in this chapter we are majorly focusing on two important aspects. One is arithmetic progression and another one is geometric progression. Before moving on to that, it is important to know about what is progression. So here progression means a number of terms succeeding one another in a definite order constitute a sequence or a progression. So if a numbers of term which is succeeding one another in a definite order, so such a sequence is termed as a progression. For example, like 1 2 3 4, so it is all natural numbers and thus were in order. This can also be an example for progression. See, the look at the second example: 3 6 12 24 48. See, every number is a multiple of number will be multiplied by 2, right? So here also there is a definite order for the sequence. Okay, so all this kind of sequences will be termed as a progression. So thus the progression means a set of numbers arranged accordingly to a definite rule is called progression. So each number in a given progression is called term of term. Okay, so here each number, like if we are considering 1 to 3, all this terms, each terms will be termed as terms. Okay, uh, and on other position in the sequence they are called see along with the terms in the sequence we are calling the first term, second term, third term, like that. We can also call the terms as a first, second, third, like that. Okay, generally in progression the first term will be denoted as a and the last term will be denoted as l. Okay, or nth term. Then we are knowing about finite and infinite sequences here. See, when the term of a sequence are limited, that means if there is any ending, that is termed as a finite sequences. So here I am taking example of 2 4 6 8. So we have only 5 terms. Okay, so 10 by 10 they are ending the sequences. So this is termed as a sequence. Here we can able to find out which is the last term easily. Okay, they have given in the example. So if they are giving the last term, that will be termed as a finite series. Okay, if we are having next one is infinite, when the term of sequences are unending or unlimited, that sequences are called as an infinite sequences. So look at the example 5 10 15 20 25, so on. So there is no end and there is no last term mentioned in this sequence. So this is termed as a infinite sequence. So then we have a series. Series is nothing but when the terms of a progression or a sequences are related to by positive or negative sign, then the sequence is called a series. Okay, so look at the example: plus 1 plus 5 plus 9 plus 13. So here it is the sequence is included with the positive or negative sign, right? So that is termed as a sequence. Well, we'll move on to the important part of the chapter. Okay, here we have a three different types of progression: arithmetic, geometric, and harmonic. So for you people in this chapter, you are majorly focusing on first two types. Okay, so let us take up arithmetic progression first. See, arithmetic progression is a sequence whose terms increase or decrease by a constant number called common difference. Okay, so here in an arithmetic progression, the term is increasing or decreasing by a constant number or common number, that is termed as a arithmetic progression. So here it is a sequence in which each term is obtained by adding a constant number. See, constant number, the common difference is one and the same. Okay, so if you are adding this constant number, you can able to um, write the sequences. Okay, or you can able to write the preceding terms. So that is termed as a arithmetic progression. See, the constant additive in an arithmetic progression is termed as a common difference. The constant additive, the constant number in the sequence is termed as a common difference, and this is denoted as D. It may be either positive or negative. Okay, so that is denoted as D. Okay, thus D is any term except the first term minus its previous term. I have quoted the example also. First term is T1, right? Second term is T2, third one is T3, T4. So except the first term, we can consider all other terms to find out the common difference. Okay, so here like I am taken the example here. Look at the example 2, 4, 6, 8, 10. So how to find the common difference for this? See, D is equal to T2 minus T1, or you can take T3 minus T4, any one except the first one. So I am not considering the first one. Okay, so T2 is 4 minus T1 is 2, then T3 is 6, T8 is, sorry, T4 is 8. The difference is 2. Here also the difference is 2. Here the number is same. That is what we said, the constant number. Okay, the constant number in the sequence is termed as a common difference. So this is how you have to calculate the common difference. Okay. uh, well, we'll move on to the next part. Okay, see, general representation and nth term of an arithmetic progression. So here arithmetic progression can be represented as, see, usually the first term will be represented as A. Okay, where D is equal to 0, so that's why we are getting A only. Second term, it is A plus D. Okay, third term is A plus D plus D, you will get A plus 2D. Similarly, the the fourth term, you are getting A plus 3D. So first term is A, second term is A plus D, third term is A plus 2D, fourth term is A plus 3D. So like this, the terms will keep on continuing. Okay, so the both terms can be generally represented as A plus D, A plus 2D, A plus 3D, A plus 4D. Okay, this is how we can represent the arithmetic progression. Okay, this is known as a general representation of an arithmetic progression, where, see, I have shown you this also. With the term also you can do this. Okay, like T1 is equal to A plus 1 minus 1 D. 1 minus 1 is 0 into D. A plus 0 into D, you are getting A, right? A plus 0 you will get. So T1 is A only. So same way you can also find T3. T3 is equal to A plus 3 minus 1 D. So 3 minus 1 is 2D. Okay, so in terms you can represent the arithmetic progressions like this. So when it comes to Tn is equal to A plus n minus 1 D. Okay, so here this is the formula we use to calculate the arithmetic progression. Okay, where A is the first term. Okay, A is the first term, n is the number of terms, and D is the common difference. A is first term, D is common difference, n is the number of term, n is the nth term. Tn is nth term. When they are asking us to find the nth term, we are using this formula. Okay, well, in arithmetic progression we are also finding the sum of an nth term of an arithmetic progression. So sum to nth term of arithmetic progression is denoted by Sn. Okay, so the general representation of an arithmetic progression will be like this: A plus D, A plus 2D, A plus 3D, so on, A plus n minus 1 D. Okay, so this is how we are going to represent when it comes to sum. Lastly, we have A plus L minus D plus L. Okay, where L is the last term, and we are using two different formula to find out the sum of an nth term. See here, the first formula is used when they have not given information about last term. So if they have given information about the last term, we are directly using with the second formula. Okay, so here also A is the first term, n is the number of terms, D is common difference, Sn is a sum. Okay, then we have arithmetic mean. So arithmetic mean of an arithmetic progression is the term or terms in the middle or in between two extreme values of an arithmetic progression. Okay, that is termed as a arithmetic mean. Okay, in between whatever the term we are getting, that is termed as an arithmetic mean. Okay, so A, B, C are in arithmetic progression. B is called the arithmetic mean between A and C. See, A, B, C, middle term will be termed as a arithmetic mean. Okay, and we are using a formula to find out the arithmetic mean also, where the formula is B is equal to A plus C by 2. Why B means B is the middle term, okay, in between A and C. That's why it is B is equal to A plus C by 2. So this is how you can able to solve the sum based on arithmetic mean using this formula. Okay, well, we'll move on. We'll take up the next concept in the chapter, that is geometric progression. Okay, geometric progression or is a sequence of number which succeeded by the constant ratio. See, in the arithmetic progression we spoke about common difference. So in this we are talking about constant ratio. Okay, what is this constant ratio? What is what is common difference? You have to know what is constant ratio, right? Okay, constant ratio called common ratio. It is a sequence in which each term is obtained by multiplying a constant number with the preceding. So here we are getting the common ratio. We are getting the sequence by obtaining by multiplying the constant number to the preceding term. Here we are multiplying, there we are subtracting. Okay, getting it? So here, to find out the constant ratio in geometric progression is denoted as R. So here the constant ratio is denoted as R. In arithmetic progression the common difference is denoted by D, right? So R is equal to any term except first term. Here also we are accepting the first term divided by its previous term. So example is T2 by T1, T3 by T2, like this. So if you are considering 4, 2, 6, 8 as a series, so how to find the common ratio? Common ratio is equal to T2 by T1. So T2 is 4, T1 is 2, you are getting 2. Same way if you are considering T3 and T4, T3 is 6, sorry 8, sorry T4 by T3. So 8 by 6, so you are getting 2 only. You have to get 2 only, okay? So that is how you have to calculate the common ratio. Okay, general representation of nth term of a geometric progression will be like this. First term will be A only, where R is equal to 1. So if you are, it is like AR, okay? So if you are multiplying A with 1, you are getting A only, okay? So second term is A into AR. Third term is AR square. Fourth term is AR cube, okay? See, it is nothing but AR n minus 1, okay? So here thus here Tn is equal to ARn minus 1. To find the Tnth term we are using a formula as Tn is equal to ARn minus 1, okay? See how we are getting AR is AR n minus 1, okay? If you are considering n as 1, it will be 1 minus 1 AR to the power 0. That is how we are getting A here in the first term, okay? Same way if you are considering the second term, that is AR 2 minus 1, so it will become AR to the power 1, so it will be AR, okay? Like that you have to calculate the terms in a geometric progression, okay? So this is how we are representing the geometric progression: AR square, AR cube, so on, AR n minus 1. Okay, well, we'll move on to the next part, that is sum of geometric progression. See, sum of nth term of geometric progression, here it will be represented as AR square, AR cube, AR n minus 2, n minus 1, okay? Is computed by using a formula. See, here we are using 4 different formulas, okay? So first one is when R is equal to 1, the formula is Sn is equal to Na. When R is greater than 1, okay, that time we are using this formula, okay? That is Sn is equal to A 1 minus R to the power n divided by 1 minus R. And when R is greater than 1, we are using the one more formula, and if there is any infinite number, then we are using this last formula, that is a by 1 minus r. So depending upon this values of r, we are using the formula. How to find out the value of r? You know, common ratio, constant ratio or common ratio. So you have to calculate the common ratio first, then you have to solve the sum. Okay, so if I'm taking example to show how to take the common ratio, yes, say for example, if the series is of okay, just a minute, I'll take the example. Okay, if I'm taking example of 2 4 8 16, okay, always it is t2 by t1, right? So t2 by t1, you're getting how much? 4 by 2, that is equal to 2. Here r is greater than 1, right? So r is greater than 1, we are going with the third formula. So like this, you have to decide the formula based on the value of constant ratio. Okay, you will understand this while solving the sum. Okay, try to remember this. All formulas are very important. Okay, and when it comes to geometric mean, okay, geometric mean is a term or a terms in the middle part or in between two extreme values of geometric progression. So here also it is in between two extreme values of geometric progression. Okay, so here G is called the geometric mean between A and B, and it will be calculated with the help of a formula G is equal to root AB. So this is the formula to use to calculate geometric mean. And similarly, if it will be represented as G1, G2, G3, G4 up to Gn are called geometric mean between A and B. Okay, so if this is the sequence, A, whatever the things we have in between A and B will be termed as a geometric mean. Okay, so this is all with respect to the theoretical aspect of progression. Okay, we're going to have a practical session on both the concept. Thank you for watching a video. Have a great day.